Today I'll discuss about process calculation for chemical engineering. Subtopic is unit convention. Now, first we must know what is unit and dimension. So, unit and dimension are two related concepts often used in the context of measurement and physical quantities. So, let's explore each term separately. So, what is unit? In the context of measurement, the unit refers to a standardized quantity used to express the magnitude and particular physical quantity. And units provide a way to measure and quantify the different properties such as length, mass, time, temperature, etc. By attaching a unit to a numerical value, we give meaning to the number and specify the scale or size of the measured quantity. Now, how do you measure? Suppose if you want to measure the mass of suppose this object, so first we have to standardize the physical quantity. Like for the mass, standard mass you just consider as a 1 kg. Standard mass is 1 kg. Now if we know how much the quantity for 1 kg of mass, then we can easily, so if that is the standard, if we know this is the standard, okay, so the one, if we know the 1 kg means what, and then we can easily measure other quantity. Like if it is a 2 kg, so just we have to give 1 kg object. Now if we want to measure 500 gram, means we have to take half of 1 kg. Similarly, we can uh, divide or multiply of 1 kg, so we can get any subset of the desired quantity of mass. Okay, like suppose you, if we want to measure this, okay, and if this is suppose the, after measuring, suppose this mass is suppose 2.5 kg, so for that we need 2 of 1 kg and half of 1 kg, means 2 into 1 kg and then 1 into 1.5 kg. So by uh, if we know the standard of 1 kg, now we can do the multiplication and division. We can get 2 kg or 200 gram, 100 gram, we can do that. So first we know what do you mean by 1 kg. So if we know the 1 kg, the standard 1 kg, so we can calculate anything. Similarly, for length, if we know what is 1 centimeter, how much it is, okay, what is the length of 1 meter, means if here if we know the 1 centimeter, then we can calculate 10 centimeter, we can calculate 100 centimeter. So if we know, so 1 centimeter means how much, okay, and we know that that full scale is nearly 30.48, means 1 feet. So 30.48 centimeter. Now if we know 1 centimeter, so then we can easily know how much is the 1 meter, how much is the 10 centimeter. So again, so 1 centimeter here is the standard. If we know the standard 1 centimeter, how much it is, and then we just do the multiplication or division, we can get the desired quantity. Like suppose if we want to get 1 meter, how much is the 1 meter? So if we know the standard 1 centimeter, then we have to take 100 times of 1 centimeter, that will be 1 meter. Okay, so if we know the 1 meter, again 1000 times of 1 meter, we will get 1 kilometer. So when I'll talk about the unit conversion, so we will know that. But here 1 centimeter is how much, so that we first know, and then we can do the multiplication and division. That way we can get the other quantity of the length. So now we understood what is the unit and how to get the physical quantity, standard quantity. Now here units classify units are two types. One is primary unit, another is secondary unit. So here, what is primary unit? So primary unit actually that is standard unit. So primary unit also known as the base unit. It is a fundamental and independently defined unit of the measurement for a particular physical quantity, and these units serve as the building block for which other units are derived, like I told you. So meter, in international system of unit, SI unit, there are some primary units. So here meter, the length, unit of length is meter. Unit of length is meter. Now if we know the meter, how much is the 1 meter, so we can derive any other units, like if we want to calculate 1 kilometer, so if we know the 1 meter, so 1,000 times of 1 meter is 1 kilometer. Like kilogram, if we mass, unit of mass is kilogram, so if we know that 1 kilogram is how much, then we can also measure what, we can also quantify what will be the that 100 kilogram means 100 times of 1 kg, so that will be 100 kilogram. Similarly, second in time, unit of time is second, electric current unit is ampere, temperature unit is Kelvin, amount of substance, that unit is mole, and luminous intensity uh, unit is candela. So these are the 7 primary units. Another two are there, so radian and steradian, solid angle. Okay, so here you have to remember that 7 fundamental and primary unit, and using that 7 primary units, so we will derive other uh, units, secondary units. Now what is secondary unit? A secondary unit, also known as derived unit, is a unit of measurement that is derived from the primary units. These units are combination of one and more primary units, often with mathematical operation involved. Secondary unit are used to express quantities that are not covered by primary units. Means, which is you can't express in primary unit, so we have to use the secondary unit. Like velocity, velocity is meter per second, so means per second, how much distance covered, that is 1 meter, so meter per second, and that is velocity. Area, that is square, length square meter. Volume, length cube means cubic meter. Force, newton, and energy, joule. So many more derived units are there. So all other units for the respective quantities are derived from this base unit. So for example, the unit newton, force is derived from the base unit. So 1 newton means kg into acceleration, mass into acceleration. So mass, the 1 newton means force unit, so mass into acceleration, so mass unit is 1 kg and acceleration is 1 meter per second square. So 1 kg into 1 meter per second square, so that 1 kg is the base unit, and again meter is the base unit, and second means time unit, that is also base unit. So if we multiply, we can easily get 1 newton. So now what is dimension? So now we understood units, so very important. So you must understood what is units and what are the primary units, what are the secondary unit. Mostly important part is you must know what is unit and what are the primary units. We have to remember by heart, then that unit and dimension will not be very difficult. And what is dimension? In physics, dimension refer to fundamental nature of physical quantity such as length, mass, time, electric charge, temperature, etc. And dimension are expressed symbolically, often using letter or symbol to represent the fundamental properties involved in the particular measurement. Right? Suppose if you want to measure some length, so how do you express length? Obviously, okay, we can say that meter. That if we express what are the quantities involved, properties involved, so we can express in the symbol or letter. So like if it is some in length is involved, so we can use L. So here dimension of length is L, we can write L. Mass M, time T, electric current I, temperature theta, amount of substance N, luminous intensity J, we can use that. Now here four system are there. So one is international system, that meter, kilogram, second system, then CGS system, centimeter, gram, second, and FPS, foot, pounds, second system. Okay, so four systems are there. Okay, so sometime that question is coming, so you have to convert that unit from unit conversion from one system to another system. So in the SI system, so length, the basic unit is meter and symbol is m. For mass, the international system, so basic unit is kilogram and kg is the symbol. Time is second and symbol is s. Electric current, basic unit ampere and a. Temperature, basic quantity and basic unit is Kelvin and symbol is k. Amount of substance, basic unit mole and symbol is mole. Luminous intensity, basic unit candela and symbol cd. And mks and international system are nearly same. So here length is meter, or international system length is meter. mks mass is kilogram, and then time is second. CGS length is centimeter and mass is gram and time is second. And FPS, the length is foot, mass is pound and time is second. So here the symbol length foot is ft, pound we write as lb, and second s, centimeter cm, gram g and time second, and kilogram kg, meter m and time second. Now here I'm giving some derived units, so we can remember that. So here speed expression, we know the distance per time, so that symbol distance is meter per s, m per s, so we can put as time and that unit meter per second. Area, length square, meter square. Volume, length cube, meter cube. Acceleration, speed per time, so speed we know that is meter per second, so that will be meter per second square. Force, mass into acceleration, so mass kg, then meter per second square, so that is Newton. Then energy, force into distance, so we know the Newton, kg meter per second square, okay, into then kg meter per second square Newton, into that is force into distance meter, okay, so kg meter square second square is the that joule. Okay, similarly power, energy per time, pressure, force per area, frequency, cycle per time, so that is hertz. Electric charge, current into time, that is coulomb. Voltage, energy per charge, that is volt. That's it for unit and dimension, that unit convention. Now next class I'll talk about unit conversion, means how to convert unit from one system to another system. That's it. If you have any question, you can email or you can write comment on that YouTube. Thank you.